Hi, Algebra. We are going to look at 12.6 and 12.7 today because they are similar and I don't think that they will be too challenging for you. I don't want to call them easy, but I think that I think you'll be able to figure them out pretty easily from the examples in the book. So I just want to go over it, and then again, if you have any questions, just please let me know. So we're focusing today on vertical translations. So that's where you take the parent function and shift it up or down. So our original function is here. This one, f of x equals x squared. And this function, g of x, where they've added 2, is simply shifted up 2. So everything's the same. It looks exactly the same, but every point is shifted up 2 points. So notice here, if x is negative 1 and you get 1 for f of x, in this one it's 3, you add 2. In this one it goes from 0 to 2, and this one it goes from 1 to 3, but all of my x values stay the same. I simply take all of my y's and they're added 2 to each one. This third one, h of x, is subtracting 2, and so it's being shifted down 2. Okay, being shifted down 2. So all of these are, you're subtracting 2. Here's the original is 1. If I subtract 2, I'm at negative 1. The original is 0, and I subtract 2, I'm at negative 2. The original is at 1, and I subtract 2, I get negative 1. Okay. So down here it says, given a parent function f of x and a positive constant c, if I take the original function and add c, the parent function is translated c units up. If I take the original function, f of x, the parent function, and I subtract c from it, then it gets shifted down 2 units. Okay. So your assignment, well, there are some examples, sorry. This shows x squared minus 3. So you're supposed to recognize what the transformation is, comparing it to the original. So this means that we're going to move our vertex 3 units down. And then they create a table, just like we've done before, from negative 2 to 2. Okay? And then you graph your function. Same thing here, this one. This one looks a little bit different because it has this negative x squared. So it's reflected across the x-axis and it's shifted. Okay? So notice here what this looks like. So when you graph it, you have this. It's been flipped and it's shifted up 2. And then this one, notice that I've multiplied by 2. So that means it's being stretched because that's greater than 1. And the subtracting one shifts me down a unit. So if I look here, it's the skinnier. This is skinnier because I'm not shifting out. Like if this were the original, it would be like this. The original, like f of x would be like that, x squared. So here I'm skinnier and I go down 1. So everything's shifted down 1 and it's been stretched. Okay, and again, they're just using those same values for x. So you'll do that for this section. For each one, you're going to compare it, looking at what's happened to it, what's happened to the x squared, and then what's happened adding or subtracting to it. Okay, and those examples will help you. Okay, and then you will graph those.
Michael Hubert.
Okay. Section 12.7 is horizontal translation of functions. Sorry, my Alexa's calling me. In 12.7, Alexa, stop. Sorry. Okay, I didn't want to have to start over. So 12.7, we're looking at horizontal translation of functions. And so we have our parent function, x squared, where we have this standard thing here. But now we are doing stuff to the x before applying the function. So our function is squaring x, and here we're adding 3 before we square it. And that changes things. Or here we're subtracting 3 before we square it. So this changes the way our function looks because it moves it around on the graph. So this is our original. Okay. Now, if I add 3, okay, and my x value is -4, okay, so if I have -4 and I add 3 to it, I get -1, and -1 squared is 1. If I have -3 and I add that to 3, I get 0, and 0 squared is 0. If I put -2 in and I add 3, I get 1, and 1 squared is 1. This here, g of x, is that graph. Notice that when I add 3 inside, okay, when I add 3 before I perform the function, I'm actually going to the left 3, which is counterintuitive, so we want to remember that. Okay, I'm going to the left 3, but when I subtract 3, I go to the right 3. Okay, so you want to remember that. That changes the way that your function moves. It isn't the same as going up means adding and going down means subtracting. Here it's kind of the opposite. Going left is when we add, and when we go right, we're subtracting. Okay? So you'll want to just keep that in mind. So this is here. Again, if I'm putting in to my function and I'm subtracting something from x, then my units are going to shift to the right. And if I'm putting into my function and I'm adding to x before the function is performed, then it's going to shift everything to the left. So the examples for section 12.7 give you examples of those kinds of functions. So here I'm subtracting 1. That means I'm going to take the original function and it's just going to be moved to the right 1 place. Okay? And so it changes the way that we find the center, okay, because it changes where our vertex is. So the table looks a little bit different because of that, because I want to go on either side of my vertex, which is shifted now. Okay, so notice here in this little table, it talks to you about how to find your new vertex. Okay. So if you shift left by adding something, then your vertex becomes -3, 0, because you added 3. Or here, if you subtract 3, your vertex becomes 3, 0, because you shift to the right. So you're going to want to find that before you set up your table, because that needs to be the middle term. And then you pick these around it based on that. So like if this were my function, I would put a 3 here for x and 0 here for my y. And then I would want to find my points around it based on that. So that's important. That's the different thing in this one that you'll want to pay attention to, is now my vertex is moving from side to side, and so that changes the x values that we use. So there are lots of examples to help you along. Okay, examples, they show you what they've done. Okay, more examples. Notice in this one they do extra things. They make it negative, so it flips, and they add 2, so it goes up 2. So this made it flip upside down. Okay, the plus 1 made it go 1 to the left, and the plus 2 out here made it go up 2. Okay, here, sorry, it's being multiplied by 2, so that means that it's stretching by 2, so it's going to be skinnier. It is x is being subtracted from. There's 2 being subtracted from the x, which means I'm going to go 2 to the right. So I go over 2. And then my subtracting 3 outside of that means that I'm going to go down 3. So here's my new vertex, and I'm skinnier than the original function because of this 2 out front. Okay, so always find your vertex first before you start your table on these, because that's going to tell you where to center your chart when you make your table, so that then you pick your x's on either side of that. Okay, you're doing the blues. This table is helpful because it talks about all of those transformations that we talked about. Okay, I'd also like for you to do the review if you have time. That would be really helpful. All right, talk to you guys later. Bye.